Can you hear me? Good.
Yeah.
Sounds pretty good. It'll be a lot more fun and interesting if you download some of the sample scripts to kind of follow along and play with. If you don't do it now, do it after the thing. You can play with it at home, whatever. But I recommend. That's why I keep putting that URL up there. So let's switch to the real presentation.
Yeah.
Yes, that's a development image from Moana, our latest film. So maybe you're wondering what the images are. This is a Pi object. This is also a Pi object. And this is also a Pi object. See? If you didn't like that humor, there's still time to go to the other. One more plug. Download the scripts if you can. You'll just find it more interesting. Later in the session, as I go through stuff, I'll actually point out what script we're using at the time, so you can pull it up. It'll be a little thing in the bottom corner right there to give you an idea where we are. Can people even see that? I guess it should be okay. And you'll also get in with those sample scripts a text file listing all the links of everything I linked to today, so you don't have to take pictures of the slides or wait for the slides to come out or whatever. They're all right there. So for this session, we're going to talk about PyObjC. I have to assume you know a little bit about Python itself, because I certainly don't have time to teach you Python. So here's a bunch of books. Read them now. You got about 5 minutes, so just go ahead. If you're interested at all in PyObjC, you might have done a little bit of web searching, a little Googling, and inevitably people come to this page right here that's asking, why is the PyObjC documentation so bad? And one of the posters really complains that there's just all this stuff. You know, what is the NS thread, detach new thread selector, to target with object, blah, 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 blah. What does it do? And there's been a really good response to that, and which I absolutely agree with. And it's, hey, bad news. The PyObjC documentation only covers PyObjC. You still need to know Python, and you might need to know a little bit about Cocoa or ObjectiveC. So there's a lot of stuff you have to learn. Really, to do anything at all useful with PyObjC, you need to know Python, and you're going to have to learn at least a little bit of ObjectiveC or Cocoa, at least enough to read the documentation that Apple has provided. So I've been talking about PyObjC. What the heck is PyObjC? It's a bridge. It's a bridge between Python and Cocoa. Cocoa is a set of frameworks that Apple has written, mostly in ObjectiveC. Some of them are in just plain old C. Python is fairly popular in the Mac admin community. There's a lot of tools out there. And because of that, PyObjC has become popular and is often used to add Mac-specific features to Python scripts. There's a lot of tools out there. Here's login log from Per Olesen, University of Gothenburg. He also wrote Auto Damage, which uses PyObjC. Graham Gilbert, who's here, and you've probably seen his presentations. Imager is written in, has a lot of PyObjC in it as well. And some other little thing that some people use or don't. This is a horror show in that it has PyObjC and JavaScript and HTML and CSS and straight C and ObjectiveC, which is really Frankenstein creation. But that's what's cool, right? You could do all that stuff and jam it together. So PyObjC lets your Python code call Apple frameworks. So you can write stuff in a language maybe you're familiar with or you're learning right now, and you can leverage Apple frameworks without having to write all of your code in ObjectiveC or Swift. But the bridge is two ways. So there are things in Cocoa that often want to call code that you wrote. Those are often called callbacks or completion blocks or delegates. And with PyObjC, you can write those things, the delegates or the callbacks, in Python, and Apple's frameworks can call your code. So it's a two-way bridge. Python and Objective-C have very, very different syntax. So one of the key things you have to learn when you're using PyObjC is how to translate from an Objective-C function definition or method definition to a Python one. And there's some basic conversion rules, and we're going to walk through some of those. So this is a very typical object method call in Objective-C. We have an object called SomeObject, and we're going to send it a message. And that message is, do something using argument 1 with some additional information that's in argument 2. And that syntax looks nothing like Python. It looks nothing like most languages out there. It's a very unique syntax for Objective-C. In fact, Swift kind of went the other direction and tried to look more like a lot of other languages. But there are very simple rules we can use to translate this syntax into something that Python can use. So the first thing we do is we get rid of the square brackets, and we use the dot notation to mean that this is going to be a method call. The Cocoa method actually has 2 parts to its name, and it sticks the arguments in between. We're going to take those and we're going to crush them together. And since Python doesn't like colons in its function names, we're going to replace those with underscores. So now all that's remaining is we need to take those arguments and stick them inside the parentheses at the end, separated by commas. Let's look at another example. Here we have a Cocoa shared workspace object, and we're going to send it a message. Please open the file, user shared readme, with the application text edit. Let's translate that to Python. First, we translate the method name by moving the 2 parts together, changing the colons to underscores, and then we put the parentheses, or the arguments at the end inside parentheses. So, fairly straightforward. Let's look at one more example. We'll take this straight out of Apple documentation. It's a little bit more complex than what we just did. So NS Workspace, here's a method here that has sort of nested calls. So the first thing we do is we create an object by calling NS Workspace shared workspace, and then we tell that object to open a file with a certain application. So when we translate this to Python, we have to start kind of from the inside and move out. So we'll start with that first interior set of brackets, and we're going to take the NS Workspace, shared workspace, convert that, and then we can convert the rest of the method call. Again, we bring the sections down, smash them together, and change the colons to underscores, and then add the arguments at the end. You might think about, what's that @ sign in the Cocoa version of the thing? That's an Objective-C-ism that says, use this as a literal string. We don't need to do that in Python. I want to point out that that rule about changing colons to underscores applies even if the argument, or even if the method has a single argument. So here we've got a, we're launching an application. There's a single argument, text edit. But when we convert it to Python, we still have to change that colon to an underscore. And it's a very common mistake to forget to do that when you're converting methods, because you kind of don't know, or you don't notice that trailing colon is there, but you have to put it there in order for it to work. Before we go any further, one last plug. Download it. Really? It's going to be worth it? All right. Let's look at another example. So many Cocoa functions that work on files want a URL, a file URL, rather than a path. So it's a very common need to take a path and convert it to an NS URL in order to pass it to another Cocoa function. So let's look at that, and to start, we're going to look at the NS URL documentation. You want to make sure, when you start looking at Apple's documentation, you want to make sure that you're looking at the Objective-C version of the documentation and not the Swift version of the documentation. Most of the documentation pages today default to Swift. So if you're searching and you find the thing that you're looking for, probably what you'll land on is the Swift version of the page. Make sure you switch over to Objective-C. So maybe we're paging through the NSURL documentation, we find a function that looks like what we need. File URL with path. It takes a path and creates a file URL. Looks like exactly what we're looking for. So there's our definition. Let's see if we can convert that into Python. So we can see that foundation is part of the, or that NSURL is part of the foundation framework. So we start in Python by importing NSURL from foundation. And then we can use the translation rules that we just talked about to convert that file URL with path method into Python. And if we run it, it worked. Let's try another method that's a little bit more complex. File URL path with is directory. So we're converting a path to a file URL, but we're giving the function an additional hint that this is going to be a directory and not a simple file. So we start the same way. We convert the method name. Again, make sure we smash the bits together and convert the colons to underscores. The parameters are at the end, separated by parentheses. We run it. And again, we have success. Notice that the URL that's generated is slightly different. It has that trailing slash on it. Now let's look at an even more complex example. This one gets a little confusing. I'll see if we can make it clear. It's not an uncommon thing to have to determine the current GUI user, especially if you're writing a script that's doing stuff and maybe your intended target is to do stuff for the current user, or maybe you need to find out if there even is a current user and do something differently, like not do the thing that you were going to do if somebody's currently logged in. And Apple has a recommended way to determine what that is, and it's on this page, this Techno page. And they recommend that you use a function called SC, Dynamic Store Copy Console User, nice long function name, from the System Configuration Framework. They even give you some sample code in C, or it might be Objective-C, but it looks more like just plain old C to me. And I'll blow that up a little bit, make it easier for you to read. The key thing is, here's the call where they're calling that function to get the name of the currently logged in user. So let's see how we might convert that to Python. First, we're going to go find the documentation. We're going to take a look at it. We see that it returns a string of some sort. And then we can take a look at the parameters that it needs in order to work. And what's really great is we take a look at these parameters. We don't really know what they are. But at the end, it tells us that we can pass null to use a temporary session. And the other parameters also say that we can pass null. So we don't really even have to know anything. We can just pass nothing, and maybe this will work. So again, we find out that this function is part of the System Configuration Framework. So we start by importing it from that framework. And remember, we found out that we could maybe cheat and use null for all the parameters. Well, the Python version of null is none. So we now have what looks like a reasonable Python conversion of this function. So we're going to run this function, and it's going to give me the name of the currently logged in user, right? That's not at all what we expected. That's a little bit more complex than what we expected. So what's going on here? Let's look at the documentation again. It says it returns a string. All right. Read a little deeper here. It returns the name, user ID, and GID. Still not really understand what's going on here. Well, as it turns out, this is a C function. C does not have the concept of returning multiple values from a function. It can return one thing. So it's a very common pattern that these functions might cheat if they need to return multiple things. And the way they do it is that some of the parameters that you pass to the function aren't actually values. They're pointers to variables that are going to get filled in later. So what actually happens is the function is called. Yes, it returns the name as the string that it returns, but it changes the values of the variables that you pass the pointers in to give us the additional things. But Python doesn't really do pointers. Python's a little bit more abstract. It doesn't let you get down and dirty and mess with memory, or at least it tries to make it very hard for you to do that. So the people who created the PyObjC bridge came up with a different way to get this to work. So when you translate the syntax of this type of function to PyObjC, what you have to do is any of the variables that are actually supposed to be pointers that stuff is going to be returned into, you just pass none for those. And then the PyObjC bridge will put those variables in the return list. So instead of returning one thing, it returns three things. In this case, our name, our UID, and our GID. And that now explains why we got that back instead of just the string that we were originally expecting. So now that we know that, we can write our script to actually take advantage of that. So now, instead of blindly expecting a string that comes back, we know that we're going to get name, UID, and GID back from that function call. And then we can print them, and it works fine. All right, that was a lot of code to look at. There's going to be a lot more, so I'm going to take a little mind break here. I was in my hotel room, and I was looking at the door. And I was struck by how complex this is. There's a lot of words there. And it's very British. Leave the building by the nominated route and assemble at the fire assembly point. And even advice like, do not tackle the fire if it will endanger your personal safety. You know, in America, we don't read that much, so our fire signs look like this. But of course, all of us in this room, this is probably more accurate for us, right? All right, back to the grind. So in order to use these Apple frameworks, the creators of PyObjC, the maintainers of PyObjC, have sort of wrapped the framework so that they can be called from Python. And they haven't wrapped all of them, but they have wrapped probably the most popular and the most used ones. It's possible to use frameworks that haven't been pre-wrapped for you. We might get to that a little bit at the end if we have time. But the ones that you're most likely going to use probably are already supported. And if you want to know, you can go to this directory on your machine and take a look at the contents. And that is the definitive list of which Mac OS X, Mac OS frameworks are available directly from PyObjC out of the box without doing additional work on your own. When you call Cocoa things, Cocoa functions or methods, often you have to pass values to them and you get values back. And values have types. Most of the types are called foundation types, or they become objects that are defined elsewhere in the Cocoa frameworks. The great thing is you don't have to worry about a lot of that. A lot of these things are transparently translated to and from their equivalent Python types. So if the function requires an NS number, you can just pass in a Python number. If it requires an NS string or it returns an NS string, you can just use a regular Python string. Same thing for dictionaries, arrays, that sort of thing. And we saw earlier that the null value maps to none in Python. So finally, let's start looking at some possibly useful examples. Let's start with the foundation framework. And we can look at the documentation and we see, okay, here's some functions that might be interesting. Here's one that returns the full username. There's one that returns the home directory, that sort of thing. And this would be the first script in the O3 foundation functions folder if you're following along at home. So we can call these functions and we get back some stuff. And really not that interesting because all of this data you can probably get with native Python functions. You don't really need to call PyObjC to get this same data. But it's still an example of something you can do to call an Apple framework. So start easy, we'll get more complex. If you're a Mac admin, you probably have heard of preferences. You may need to manage some preferences. You may need to read them, you may need to alter them. And you may have used something like the defaults command in a bash script or some other kind of script. You can get a little bit more granular if you use Apple's Core Foundation CF preferences utilities. And these are a set of low-level functions for accessing, reading, and writing Mac OS X preferences. So here we're going to read the setting for show hard drives on the desktop in Finder's preferences. And you might think, so what? That's really easy to do in defaults as well. You know, I can just say defaults read com.apple.finder show hard drives on desktop, and I get the same thing back. Well, close. There's an important difference, and let's look at that. So this is the second script in the Core Foundation folder. We're going to do sort of a comparison here. First, we're going to get the value for this preference using the defaults command. I'm going to use the subprocess module, shell out to the defaults command. I'm going to get that value, print it. And then I'm going to do the same thing using the native CF preferences function. So defaults gives us, well, we get 1 back, so that sounds like a number, but Python tells us it's actually a string. And if you notice, there's a line break after the 1, so we're actually getting 1 carriage return back from the function. So if we're trying to find out the setting, if it's on or off, true or false, we're going to have to do a little translation or conversion of that string value that we got back. However, CF preferences gives us an actual Boolean value. We don't have to translate it. This gets a lot more important when the data that the preference data that you're getting back is more complex. So the value of the Finder's standard view setting is actually a dictionary. So if you read standard view settings from com.apple.finder, you will get back a dictionary. And so what you really need is a little tiny piece of that. That can actually be very difficult to do using the defaults command. So again, we're going to do this both ways. We're going to use the subprocess to call defaults, and then we're going to get the same value using CF preferences. And then after we do that, we're going to print a tiny little piece out of that value we got back. So let's run it. And defaults gives us this big, long string. Multiple lines, line breaks, lots of characters in there. And so if what we were interested in was simply the calculate all sizes value, we're going to have to figure out how to parse this string. You know, we could pipe it to grep and awk and cut and all that stuff. And we could probably get the value out, and we thought we would be really clever. But if instead we use the native CF preferences, we get back a standard, an object that we can treat like a standard Python dictionary, and we can use Python's dictionary syntax to find the one little bit of information that's buried inside that dictionary that we want. So the more complex data, the better it is to use these functions because it just makes things way easier. We can also use the CF preferences functions to set user preferences. And here we're going to set the Finder's show hard drive on desktop preferences to false. So very similar to using defaults right. Again, if you're using something more complex than a single value, the CF preferences, it becomes much more appealing thing to use. So there's some fun stuff in the AppKit framework. Bye, Joel. Bye, James. If you're working with a GUI or writing a Python Cocoa application, you're going to use AppKit. And we're going to just look at one small part, which is NS Workspace. And NS Workspace lets you do some stuff that's very Finder-esque. You can launch applications, you can open documents, that sort of thing from your Python script or from any code that's calling NS Workspace. So this is the first script in the AppKit NS Workspace folder, if you're following along. And we start by importing NS Workspace from AppKit. And again, you'd have to read the documentation on NS Workspace, but in order to do anything interesting, the very first thing that you have to do is get what they call, what Apple calls the shared workspace object. So that's what we're going to do here. And then we can ask that workspace object to do things for us. In this case, we're going to ask it to retrieve the full path for a certain application name, in this case, Microsoft Word. And then we can also ask that object to launch Microsoft Word for us. So let's run it. Great, it tells us where Microsoft Word is, and it launches it for us. We can also ask the workspace object for a list of running applications. Pretty easy looking method name, running applications. We get something that's a little funky looking, but we can kind of guess at what it is, because it nicely puts some, at least some bundle identifiers in there, so we can kind of get a feeling, okay, there's a login window, touch bar agent, terminal, text menu. See, I kind of understand. The list is not a list of application names, it's a list of NS running application objects. So the next thing you do is go look up the documentation for the NS running application object and see what it can do. And it has a bunch of methods that might be interesting. So we can do the same thing where we get the list of running applications, but now we can go through that list, iterate through it, and print the localized name. And you run that, and you get then a human-readable name for each application that's running. And if your machine is set to non-English language, you will see the localized name, the same one that you would see in the Finder for those items. We can also get a lot of extra detail for a specific running application. Here we're going to look for something running that's com.apple.terminal as its bundle ID, and then get some different information about that. So, okay, the localized name is terminal. There's the bundle URL. In other words, where is it on disk? When was it launched? That's kind of interesting. And is it currently hidden? Another thing we can do is we can bring an application to the front. So again, we can loop through the list of running applications looking for a bundle ID that we're interested in. And once we find it, we can tell it, hey, bring that to the front. And so it does that. So if you're used to using AppleScript, maybe to control other applications, this could be a really nice replacement for that if you're moving to Python. So instead of tell application Microsoft Word to activate, types of thing that you would do in AppleScript, here's a little bit lower level way you can do it directly from Python. So here's another fun example. We're going to use AppKit objects and methods to change the current desktop picture. We're going to import a couple standard Python modules and some stuff from Cocoa. NS Workspace we've looked at. NS Screen is objects that manage the displays. And we've already looked at NS URL. We use the glob module to give us a list of all of the JPEG files in in the library desktop pictures folder, and then the random module to pick one of those at random from that list. We can convert that path then to an NSURL object, which is what we need later. Here's that shared workspace object that we keep getting in all of the other examples. And finally, the new bit, which is we're going to go through all of the connected displays. That's what the NS screens gives us. So for screen in NS screens, nsscreen.screens. And we use Workspace to set the desktop picture to that random picture that we picked. So we're going to see if the video switching works here, and I'm going to demonstrate that. Let's try it out. I think we discovered before the session started that I had to use the system preferences pane to switch to mirroring. If you did it via the menu bar, it didn't work. Okay, good. So let's get rid of that stuff. We're going to get rid of that. And I shouldn't close that, I should hide that. Okay, so I've got a lovely, lovely background image. Love it a lot. But I'm going to run that script. Again, it's in your sample stuff. And it will select a random picture. I can run it again, and again, and again. And so if you're really evil, like some people I saw on a certain vendor forum, which I will not name, you could maybe make a cron that runs this every hour or every 5 minutes, every minute. I'm sure your users will love you. They will sing your praises. So I don't know if this actually has a real application, but you could use this maybe to set an initial default company-approved desktop picture for your users. Obviously, you can manage desktop pictures with profiles, but then the users can't change those. This would let you set a initial desktop picture, but then the user could then change it to something that they like better. You know, for example, maybe I still like this. Let's do that one. All right, now let's see if we can switch back the slow and boring way. No, arrangement. Let's see if everything, yeah, good, okay. Good. So a fairly recent addition to Mac OS is the Notification Center, which can display banners or alerts at the upper right corner of your screen. And we can call that from Python. Notification Center is actually fairly complex to use. So you're going to do a lot of reading, or you can cheat and at least start with the sample scripts that I've given you and build from there. And these sample scripts are all in the Notification Center folder in the sample scripts thing. We're going to do something really basic first. We're just going to do the bare minimum we need to display an alert. So first we create a user notification, and we set a title, subtitle, detail text. We get the default user notification center. This is like boilerplate. You will always have to do this. You don't really even have to understand it. You just do it every time. And then you tell that notification center to deliver your user notification. So we encapsulated that in a function. We can call the function, and we say, and we're going to call it with the message that updates are available. And if we run that, we get a little notification. But that icon is really funky, isn't it? It's like a rocket ship icon. Well, it turns out that that's actually the icon that if you ever launch Python, Python is implemented as an application bundle on OS X, and that's the icon for Python. So we probably don't want that. We would rather have an icon that was relevant to the message that we're trying to get across. And I use Monkey. The message I was trying to get across is that there are updates available, so maybe I want to display the Managed Software Center icon. Well, it turns out that Notification Center displays the icon of whatever application it thinks posted the notification. So we really should be posting this notification from Managed Software Center, but that's not what we're doing. We're posting it from a Python script, and that's why we get the Python icon. So is there some way we can cheat? And it turns out, yeah. Every application has a info dictionary. It's the one you usually see in the bundle's info plist. And that's supposed to be read-only. But Michael Lin, also known as Frogger on IRC and Slack and those sorts of things, found that at least inside Python, you can write to that. You can change it. So we're going to take advantage of that. We're going to write a little function here that reads the info dictionary from our bundle. In this case, it would be Python, since we're running this under the Python interpreter. And then we're going to overwrite the bundle identifier with the ID of the application we're interested in posting this notification center as. And so we can add that bit to our notify function, and we can add that as a parameter when we call it, so that I have the message that I want to send, and then I say that my bundle ID is the bundle ID for the Managed Software Center application. In this case, com.google code.monkey.managed software center. So if we run that, now we get a notification with the icon that we wanted. Now, if you were to click on that notification, it would do absolutely nothing. So now we need to read the documentation a little bit more. How do we react to clicks? Well, it turns out that you have to create a delegate object, something that Apple's code can call in your code to tell you that something has happened with the notification. And this is an example when we talked about the bridge being two ways. We're going to write code that Apple's code is going to call. And so what we create here is a notification delegate. That name isn't special. That's just the name I picked for this. And it subclasses from NSObject. NSObject is an actual object from Apple's code, and we're subclassing an ObjectiveC object in Python. The only message that the delegate sends that we're really actually interested in right now is user notification center did activate notification. That is the notification you get when a user clicks on your notification. Confusing because Apple's using notification to mean multiple things here. But let's rephrase it as this is the message that your delegate is sent when the user clicks on the notification. So what we're going to do when the user clicks on that is we're going to launch the app that we cheated and pretended we were. So we write a function that gets that bundle ID that we set, and then we launch the app based on that bundle ID. Now I could have used NS Workspace, and that would be the correct way to do things, but I was lazy. I'm just going to use open to open the application. So now we have to add that code to our notify function. We create a delegate object, and we tell the notification center to use that as by using the set delegate method. So the notification center set delegate my delegate object. And after we post our notification, we have to wait around to see if the user does anything. This is not ideal. If you were actually writing this for production, you'd want to handle this a little bit differently, but we're going to do this for this demonstration. And let's demonstrate that then. All right, so one thing is I've got to turn notifications back on because I've turned them off for this presentation. So you wouldn't get embarrassing emails popping up in the middle of the notification. So this is the complete script that I was walking through in the slides. And if we run it, get a notification up in the corner there, and then if I click it, it launches Managed Software Center, which is exactly what I wanted. I'm not connected to our network, so it's not actually going to do anything. We can take this a little bit further, so I'm going to quit that. And notice that it opened Managed Software Center, but it only went to the kind of the main page that shows the optional installs. I would really rather it go to the page that shows any available updates. And we can do that. That's in the next script, 04. And the key things that are different there is that when we get that notification or that message that somebody has clicked on our application, we can, instead of just opening it, we can open a URL. And since Managed Software Center knows how to respond to certain URLs, that URL can simply be, I didn't want to do that. That's nice. Go away. Okay, and then that did a fun thing. All right. Hello. There we go. So that URL is simply monkey / updates. If I run that, not only do I get the notification, but when I click on it, it launches Managed Software Update or Managed Software Center and goes to the updates page. I don't actually have any pending updates right now, but if I did, they would be listed right there. So that's some cool stuff you can do. And yeah, we have a couple minutes here. I want to do one more possibly interesting demo. This is one of the newer MacBook Pros with the touch bar and Touch ID. And I want to interact with Touch ID with Python. And I can do that. Again, the documentation, it turns out that local authentication is the framework that we want. And local authentication is not wrapped natively in the Python that's shipping, but the maintainer has wrapped it on, and you can download the files needed to talk to the local authentication framework. I've done all that in the demo scripts that I've given you. But once we have that, we can write a function or a set of functions here that lets us authenticate with biometric information, which means use the Touch ID. And it looks a little bit like this, but you can't see my touch bar here. So I'm going to launch this fun little app called Touche. And it is not working properly because I'm not seeing anything in it. Let's see what happens if, there we go. Okay, so this is the sort of thing that pops up. Interestingly, why is it not showing there? Now it's starting to catch up. Good. So if I run my script, which is the local auth demo script, what happened there? Okay. We can see down here, I'm standing in front of the cool part here, is I'm simply going to authenticate with the reason to purchase chocolate. So if I run that, and it's not, you're not seeing it on the display. That's so annoying.
Yeah, but it's there.
The arrow's there, but the message that I see on my and this worked the last time I tried this, the message I see on the touch bar is it says Touch ID to purchase chocolate. And the arrow is pointing. So if I touch it, you notice that dialog went away, and I was able to purchase chocolate. Let's try it again and see if it actually does something. If that's kind of disappointing. No, all we see is the stupid little bouncing arrow. Very annoying. So I canceled instead of authenticated, and nope, no chocolate for you. Well, that's unfortunate. It worked at home. But so you can't see what's going on here, but it does work. So I can actually, with Python, integrate with Touch ID, ask the user to authorize something, and get it back that they've used the Touch ID. All right. I think we've got like 1 minute. If anybody has any questions, they better be good ones.
Hello. So with Python and Objective-C, if you're going to look at building an application within Xcode, can you just create a load of Xcode and just create an app that way, or is there anything that needs to be done for that to work?
That could be another 45-minute session. There are different ways you can create full applications using PyObjC. The one I've used the most, and I think most of the ones I mentioned, the login log and Graham's imager and some of that other stuff, you can use an Xcode framework or an Xcode template called CocoaPython app, and it kind of creates all the starter framework for you to at least get a window up, and then you can then design your windows in the interface builder interface, and you can then connect buttons to functions inside Python and all that sort of thing. There are ways to do it without Xcode. You can just write raw Python and do a full-on application. I've not played with that myself because I like being able to design the UI with a GUI instead of numbers in a grid and that sort of thing. But yeah, that would be another whole 45-minute session just walking through Xcode. Because who here's used Xcode? Would you call it the easiest program ever to do things in? It's fairly complex to even do very simple things in Xcode, and so yeah, you'd have to. I could talk about it, but it would be it's not something I can cover in a minute.
Cool, thank you.
Anyone else? Everyone wants to go for a coffee break.
Excellent.
Easy. Cool.
All right, thank you, everyone.